Imagine a world with no sound of birds. No wind through trees, because there are no trees. No blue sky, because the sky isn't blue yet. Just a violent orange sun rising over a purple ocean, under a toxic haze of methane. Now imagine, somewhere in that ocean, in a crack on the seafloor where scalding water meets freezing dark, something moves. Something lives. It has no eyes. No brain. It's smaller than a grain of sand. And yet, that single, invisible spark is the ancestor of every living thing that will ever exist on Earth. Every dinosaur. Every whale. Every human being who has ever taken a breath. This is the story of the moment life began. This is the Archean Eon. By 4 billion years ago, Earth had survived its violent birth. The Hadean Eon, that hellish, molten beginning, was finally cooling down. But don't picture anything peaceful yet. The sky above Archean Earth was alien. The sun itself was dimmer, nearly 30% weaker than it is today. And yet, somehow, Earth wasn't a frozen wasteland. Scientists call this puzzle the faint young sun paradox. The likely answer, a thick blanket of greenhouse gases, methane and carbon dioxide, trapped enough heat to keep the planet's brand new oceans from freezing solid, yes, oceans. This is the moment they appear. As Earth's crust cooled and solidified, water vapor in the atmosphere condensed and fell, in rains that might have lasted thousands of years. Comets and asteroids, still crashing into Earth from the chaos of the early solar system, delivered even more water and organic material. Slowly, the first global ocean was born. Shallow, warm, mineral-rich, and covering almost the entire planet. There was no land to speak of yet, just scattered volcanic islands poking through the waves, spewing ash and lava into a sky tinted a hazy orange-brown from methane gas that if you stood on one of those islands and looked up, you would not see a blue sky. You'd see a strange, dim, copper-colored haze, Earth wrapped in its own primitive atmosphere, with almost no oxygen at all. This was the nursery. And inside it, something was about to happen that would change the universe as far as we know it. This is the biggest mystery in science. How do you go from chemistry to biology? From rocks and water to something that's alive? Nobody knows for certain. But scientists have powerful theories, and the leading one takes us to the bottom of the Archean Ocean, to structures called hydrothermal vents. Picture towering chimneys on the seafloor, spewing mineral-rich, superheated water from deep inside the Earth. Around these vents, in the cracks and pores of the rock, conditions were just right. Warmth. Chemical energy. A constant flow of molecules like hydrogen, carbon dioxide, and ammonia, over unimaginable stretches of time, millions of years of chemical trial and error, simple molecules began linking into more complex ones. Amino acids. Fatty molecules that could form membranes. And eventually, something extraordinary, molecules that could copy themselves. Self-replication. That is the line between chemistry and life. Once a molecule could make imperfect copies of itself, evolution had something to work with. Mistakes, mutations, meant variation. And variation meant some copies would survive better than others. We call the very first living things LUCA, the Last Universal Common Ancestor. Not the first life that ever existed, but the earliest ancestor shared by every living organism on Earth today. LUCA likely lived somewhere between 4.2 and 3.8 billion years ago, right here in the Archean. LUCA wasn't a plant, an animal, or even a proper cell as we'd recognize one. It was a simple, single-celled organism, a prokaryote, with no nucleus, no complex internal structures. Just a membrane, some genetic material, and the ability to survive and multiply. And here's the astonishing part, we have proof it happened almost the moment conditions allowed. Some of the oldest rocks on Earth, in Greenland, dated to 3.7 billion years ago, contain chemical signatures that strongly suggest life was already present. Life didn't take billions of years to get started. It may have emerged almost as soon as Earth cooled enough to host it, which raises a haunting question scientists still debate today. If life appeared this fast, this easily, on early Earth, how common might it be, right now, on other worlds, for hundreds of billions of years, life stayed microscopic, invisible without a microscope humans wouldn't invent for billions of years. But by around 3.5 billion years ago, something remarkable started forming in shallow Archean waters. The first structures built by life that you could actually see that they're called stromatolites, layered, dome-shaped mounds built by colonies of photosynthetic bacteria called Cyanobacteria. Each day, these microbial colonies would trap sediment and minerals in sticky mats, then grow a new layer on top. Year after year. Century after century. Slowly building rocky structures that could grow for thousands of years. Here's why stromatolites matter so much. Cyanobacteria were doing something no organism had ever done before. They were performing photosynthesis, using sunlight to convert water and carbon dioxide into energy. And as a byproduct, they released a gas that, at the time, was essentially a toxic waste product to nearly everything alive. That gas was oxygen. Astonishingly, stromatolites aren't just ancient history. In a handful of places on Earth today, most famously Shark Bay in Western Australia, living stromatolites still exist, built by the direct descendants of these Archean pioneers. When you look at them, you are looking at a living fossil, a direct window into the world of 3.5 billion years ago. At the time, oxygen from these microbes didn't fill the atmosphere, not yet. The oceans, the rocks, and iron dissolved in seawater soaked it up almost as fast as it was made. But cyanobacteria were patient. And they had billions of years ahead of them. They were quietly setting a slow-motion time bomb that would later detonate into one of the most transformative events in Earth's history, the Great Oxidation Event. But that story belongs to the next Eon, the Proterozoic. While life was quietly evolving in warm shallow seas, the planet above and around it was still incredibly hostile by modern standards. There was almost no ozone layer, which meant deadly ultraviolet radiation from the sun bombarded the surface unfiltered. This is likely one of the reasons life stayed in the ocean. Water offered protection that dry land simply couldn't. Meteorite impacts, while less frequent than the Hadean, were still far more common than today. Volcanic activity was intense, as Earth's interior was much hotter and more active, driving the movement of the first protocontinents. Speaking of continents, this is the era when the first stable landmasses began to form. Through volcanic activity and the gradual cooling of Earth's crust, small cratons, ancient cores of continental rock, started to emerge from the global ocean. Some of the oldest rocks on Earth still found today, like the Acasta gneiss in Canada, formed during this Eon, around 4 billion years ago. Earth's day was also shorter, possibly as short as 15 to 18 hours, because the Moon, formed from that violent collision in the Hadean, was much closer to Earth and Earth was spinning faster. A closer Moon also meant colossal tides, far more extreme than anything we experience today, constantly reshaping Archean coastlines. And the sky wasn't just hazy, it may have had a genuine orange or brownish tint from a photochemical smog created by methane reacting with sunlight, similar to the haze scientists see today on Saturn's moon Titan. If you could travel back and stand on an Archean shoreline, you'd be looking at something almost unrecognizable as Earth, and yet, right at your feet, in the tide pools and the shallow seas, the entire future of life was already quietly unfolding. It's easy to think of the Archean as just a warm-up act before the real story of Earth begins. But that's completely backwards. Every single form of life that has ever existed, every plant, animal, fungus, and human being, descends from organisms that first appeared in this Eon. The basic machinery of life, the genetic code written in DNA, the process of photosynthesis, the concept of a cell membrane separating life from environment, all of it was invented here, in the Archean. Think about that. For roughly 1.5 billion years, nearly a third of Earth's entire history, life existed only as simple, single-celled microbes. No eyes. No movement as we'd recognize it. No predators or prey. Just an ocean quietly experimenting with the chemistry of existence, and yet, in that boring, slow, microbial world, cyanobacteria were doing something no volcano, no comet, no asteroid impact ever could. They were changing the entire chemistry of the planet, filling the oceans, and eventually the sky, with oxygen. They were building, atom by atom, breath by breath, the very air that would one day let fish crawl onto land, let dinosaurs roar, and let you breathe. As you listen to this sentence right now, the Archean isn't the boring prequel. It's the Eon where the rules of the game were written. So the next time you take a breath, remember, the oxygen in that breath has a 3.5 billion year history. It started as a waste product, released into a poisonous world by a humble microbial gnat on some forgotten Archean shoreline. That patient, invisible process didn't stop. It built up. Slowly. Relentlessly. And in the next Eon, the Proterozoic, it would trigger one of the most violent transformations Earth has ever seen, an event so severe, it very nearly wiped life out entirely, before rebuilding the atmosphere into something new. We call it the Great Oxidation Event. And it's where our story continues. If you want to see how a toxic gas nearly destroyed early life, and accidentally created every animal that would ever exist, make sure you're subscribed, because part 3 is coming next.